I'm waiting for the internet is there somehow. So I'm waiting for the internet to. I'm waiting for the internet is there somehow. So I'm waiting for the internet to give us the opportunity, the internet to give us the opportunity to share our link. I'm waiting for the internet is there somehow. So I'm waiting for the internet to give us the opportunity, the internet to give us the opportunity to share our link. Can you see my screen? The opportunity, the internet to give us the opportunity. So we are good to go now. Yes, I think we're fine. I want to confirm, can you see the board? Left. That I directed you guys to write your matric number. So left V is not your matric number. It will be the internet, the Zoom will allow you to rewrite your name so that you can have your matric number. Olaleye, can you unmute yourself? Can you see the mic? Can you see the screen? Sorry.
Yes, I can see it, sir.
Thank you. What did you see on the screen?
Science and technology.
Yes, I wrote something on the screen. Can you see that?
Dr. S. Not
That's
really,
what I
sir.
want to confirm. So that means you can see the screen. Thank you. So sorry about what happened on Monday. I thought as I was talking, I was also sharing my my screen. I didn't realize that I wasn't sharing my screen. It was until after the lecture that I realized that I didn't share the screen. I will not waste time because we've discussed most of the things on this slide. We've looked at science and technology, definitions of science and technology, importance of science and technology. We've looked at a lot of things on science and technology. Oh, one more thing. I'm supposed to be recording this. Oh, record. Yes. So I would not want us to waste time again on this because we have looked at science, definitions of science, importance of science we've discussed. Then we've also looked at methods used by scientists to the methods of scientists, yes. We know already that learning new facts is part of the work of scientists. Science is about solving problems. For instance, the problem of delivering lectures to over 3,000 students in a small room. The one we have in DLI, we have 3 rooms that cannot take all the 3,000 students or more. And so as a result of science and technology, we've been able to overcome that problem by using Zoom. And we are also able to stream live on YouTube. So these are some of the these are some of the things that science and technology have been able to solve for us. Years ago, if I want to watch television, it's always on black and white. But I'm very sure most of you on this platform now do not know anything that we call black and white television. It's now colored television, and we have different types of colored television now. And so these are some of the benefits of doing science. And I think thereafter, we also looked at the various methods that scientists always use in achieving the challenges. And we saw most of them. We saw also that science is technology is what we can refer to as applied science. And science is also applied technology. We discussed all this on Monday, so I don't think we want to go over this again because of time. In addition to this, I think we also looked at the methods that scientists always used. And I remember mentioning that the success of science is more to do with attitude and not just a particular method. And what is the attitude? I mentioned it last week, on Monday, that the attitude is one of inquiry. They make inquiry, they ask questions. They inquire, ask questions, then they carry out experiments. And because they are not sure of what the final answer is going to be, humility before the fact, before they eventually get the facts, they are humble and they wait for the final answer before they now sit down to analyze results. So the steps that scientists always use, we said there are many, but the first thing is they observe things. I asked myself when I came in now, why is it that I wasn't able to mute all of you? And I tried to mute the noise. It wasn't possible. So I logged out. And when I tried to come in again, I was told, sorry, the Zoom can only take 300 and is already filled to capacity. As a result, I wasn't able to come in to use the Zoom link. So, but luckily for me, maybe one of you decided to leave, and now I was able to come in. And so scientists will ask questions. They now propose hypothesis, a hypothesis that is testable. And from there, they can develop theories and laws. So we discussed all this the other day, and I'm very sure you also have information about it because I sent these slides to you via your class reps. I think we are looking at, I mentioned that there are 3 things that we always looked at. We are supposed to compare hypothesis with law and theory. Yeah, this is the stage. Hypothesis, theories, and law. So this the remaining slides looked at the three of them and tried to differentiate, try to give differences between them. Already we know a hypothesis is a prediction that can be tested. So we say it's an educated guess. It is a tentative explanation or idea about how things work. It must be a statement that must be tested. If it cannot be tested, then it's not a hypothesis. So it must be tested by observation. There must be observation that we can make to tell whether the hypothesis is correct or not. And a hypothesis that is not testable is speculation. And you remember I mentioned, I used that general speculation that people believe that when rain is falling, the sun is shining at the same time, then they believe lion is giving birth in the jungle. This is not, it's just a speculation. It's not something that is testable. And so in looking at scientific method, hypothesis play a strong role. And so hypothesis is about formulating a question, make a testable prediction, carry out experiments, then look at your result and analyze it. For a hypothesis to be accepted, it must be tested and retested many times before it is generally accepted in scientific community as being true. It guides you further to get a better answer. Now, theory. What is a theory? A theory consists of one or more hypotheses that have been supported with repeated testing. A theory is not a wild guess. It's not a wild guess. It must be consistent with known experimental results, and it must be able to predict things. It should have that predictive power. A new knowledge is gained. As new knowledge is gained, theories are refined. I remember using that of Dalton's atomic theory. In Dalton's atomic theory, which you all know, we have information that atom is the smallest indivisible particle. But like we know now, and after this lecture, the next lecturer that will come in, we give you information about how we move from atomic theory to what we know today. The information that made us to know that atom is no longer the smallest indivisible particle to what we know today as proton, neutron, and electron. So we are going to have that information. Theories are widely accepted in scientific community as being true because series of experiment has been done on it. And to remain a theory, it must never be shown to be wrong. If it is, the theory is disproven. And we've talked about evolvement of theories. Theories do evolve. This means the old theory wasn't wrong, but it wasn't complete either. And that is what we know about Dalton's atomic theory. We have not discarded it. We never want to discuss atomic theory. We always start from Dalton's atomic theory. And from there, we now take it to the level that we know today. And you can see the level that we know today has made it possible for us to look at, if, for instance, if one asks you to write electronic configuration instead of sodium, which is number 11, instead of writing it as 281, I now know with the new theory that rather than writing it as 281, I will write it as 1s2, 2s2, 2p6, 3s1, like that. So the theories can evolve. This means that old theory wasn't wrong, but it wasn't complete. So within the context of science, a theory is a well-substantiated explanation of some aspects of natural world, and is based on facts that have been repeatedly confirmed through observation and experiment. So it wasn't that they just discarded Dalton's atomic theory. Before arriving at what we know today as proton, neutron, and electron, series of experiments were done. And today we arrived at what we know as the new way of writing electronic configuration. So most of the information you have there are just repeated. A theory is a synthesis of well-tested hypotheses. So once your hypothesis has been tested correctly, it can graduate to become a law. A hypothesis is not a law, but combination of the information from hypothesis is what will now make a hypothesis to graduate to become a theory, to become a theory. So a theory is a synthesis of well-tested hypotheses. Now, so theory, some of the examples which I also mentioned on Monday are theory of evolution, theory of relativity, atomic theory, quantum theory. And we all know about this. Physical theories tend to be highly mathematical in nature. For instance, quantum theory is highly mathematical, and we have used it to solve a lot of problems. Then the third is a law, scientific laws. How is scientific law different from theory? A scientific law is a powerful summary of many facts. So laws describe what happens. They don't generally explain why they happen. Laws can often be expressed very conveniently and concisely. The volume of a given mass of gas is inversely proportional to what? To the temperature provided, or to the pressure provided. You all know that Boyle's law and Charles' law. So laws can be expressed mathematically. Can I also ask? I just want to be sure again. Olaleye, I hope you can hear me.
Yes, sir.
Thank you very much.
Yes, sir.
So mute. So a law Within the context of science, the statement that is based on repeated experimental observation that describes some aspect of natural. So you can say it's like theory, but the difference between them are some of the things you're going to see. Laws are often expressed using mathematics. Note that a theory can never be upgraded to a law, as they are completely different things. You can always replace laws and theories if you have new evidence. But as long as you don't have new evidence, they will remain the way they've been confirmed. So a law is a mathematical relationship that is consistently true. So it relies on, and you can see that single expression, single mathematical expression, PV is equals to nRT is Heidegger's law. Beer-Lambert's law, you can see absorbance is equals to what you have there. So all these are some of the things that you must know, and go through the slides. We have given you, is just to guide you. You can look for more information. So how are they related? The three of them, hypothesis, theory, and laws. How are they related? A theory is more like a scientific law than a hypothesis. A theory is an explanation of a set of related observations or events based upon proven hypotheses and verified multiple times by a detached group of researchers. So it's not that I have proposed a theory, I'm in Nigeria, and I believe the theory that I've proposed will be accepted if others outside Nigeria have not tested it. So we always have people testing it. If you tell us the volume of a given mass of gas is directly proportional to the temperature, provided the pressure is, so we are going to test it here, test it in another country, and at the end of the day, we agree with you. So we always have detached group of researchers trying to agree or disagree with you. And that's the reason why when we do research, we always put our research findings, we send it. We go to conferences to present our work. We send it through journals for people to review and agree or disagree with us. So it's not that you just think you do it here and you think people will accept it without others testing it. A law governs a single action. So whereas theory explains an entire group of related phenomena. One scientist cannot create a law. He or she can create a hypothesis. One scientist cannot create a law. So it's always combination of efforts put together that people call a theory. So one scientist cannot create it, but one scientist can create a hypothesis, which people will now test. A scientific hypothesis is testable and it could range from why apples fall from trees. You ask yourself that, why apples? Why do apples fall from trees? Scientists, we should be able to answer that. That's a good hypothesis to now carry out experiment on, and we can put our data together to see whether we can get something out of it. The same thing, why Homo sapiens walk upright on two legs. we can find answers to that because they are testable. So a theory is most elaborate. It's simply the most elaborate form of consistent scientific theory. It's difficult to prove a theory, but you can disprove it. And so you can look at this, is giving you, you will not appreciate it in the slides you have. But looking at this now, you can see you have a problem. You start with a problem. You ask yourself questions, after which you propose a hypothesis, a testable hypothesis, and you now carry out experiment. Series of experiments, you carry out series of experiments, after which your result can now make it possible to say, oh, I have a law or I have a theory. And you can see it must be well tested before it can develop to become a law or theory. And if it's not well tested, then it will go back to hypothesis, which you now need to reformulate your hypothesis. Then you set it again to carry out your experiment. For instance, we said something about you trying to put on a torchlight, and you observe that you trying to put it on and the torchlight did not come on. Then you now ask yourself, maybe the battery is dead. And so you carry out experiment by removing the battery in the torchlight and putting a new battery. Then you put it on again and you say, oh, yes, after putting it on, the battery was able to give you the expected light. And so you can now sit down to put some things together. And if after putting battery, the torchlight did not, after putting new batteries, the torchlight did not come on, then you can ask yourself, maybe it's the bulb again, and you carry out another experiment on the bulb by changing that. So by changing the bulb and putting another bulb, or changing the battery and putting another battery, you are carrying out an experiment, and you can now decide to put your data together to write your final results. So you can see hypothesis, you must support it with several experiments before it can graduate to become a theory. And from theory, you can take something out of it to make it become a law. And so these slides has information about differences between laws and theory, laws and theories, and you have them on the slides that I sent to you. So I will advise you to go through all that. Science, please note that please pass information to others, because we started with 250 something students. It has reduced to 166. The way we are doing it now is the way we are going to do it throughout the semester. And I can assure you, we are going to have tests on this platform as well. So prepare yourself for the test. We can have our test anytime. You can see on this platform now we have Q&A, and you'll be expected to submit your answers through the Q&A. And so for those on YouTube, they will also be able, I think they will also be able to do that. We are going to confirm all that before giving you the opportunity to do all that. So what you have now, you'll be able to see the differences between hypothesis, law, and theory. So I think I want to, because I wasted about 15 minutes or so coming online, and as a result of that, Why are articles? These are some of the questions that we can ask you. One of them is, why articles in scientific journals the most reliable source of information about? You remember I mentioned on Monday that we have different ways by which we communicate our results. Why is it that scientific journal is the most reliable source? And these are options. So one of them is correct. Maybe you want to send your answer. I don't know if it's possible now because I disabled everything in order to be able to have sanity. And straight away, the answer to that is that. So if you answer is not A, then that means you've missed that. And if you see something like that in the exam, I believe you'll be able to answer it. And so these are some of the things you can see. The figure below shows how scientific experiment can lead to laws as well as theories. You can see observations, hypotheses, which may be revised based on experimental data. Then you have experiments. An experiment can lead to observation that support or disprove a hypothesis. Then you now have scientific law. A scientific law summarizes the result of many observations and experiments, and that can also lead, you can see, from experiments, it can go to theory, and theory back to experiments, and from there you can get law. So you must understand the route through which we get all the methods that we use. I think the last part is, you can see, if you look at this information as well, you're going to see that we have all the methods that we've discussed. All of them are fully shown in this flow chart that you can see here. So I think that's the end of this part of the lecture. The second part, which I'm also going to introduce today, is what you know very well. We'll be looking at state of matter. We'll be looking at state of matter. Favor, Friday. You can unmute yourself, Favor, and ask your question.
Yes, sir. Sir, we can't type our matric number on the Zoom, so we can't show our presence, sir.
You can type it.
Okay, sir. Tell me what the people WhatsApp. Sir, I can't still type it now. It's still disabled.
On WhatsApp or Zoom?
No, on Zoom, sir.
It's disabled. It's okay. Lecture note, lectures. B2. So, are we still on? If I don't do this, we will not be able to get. So I want to share my screen again. And the screen I'm sharing is that of matter. What is matter? I'm very sure you can see my screen now. Can you see this now? Iyanu, can you see
Yes,
the
sir.
screen?
Yes, sir. I can see.
Is my name on the screen? What can you see on the screen? I just wrote something on the screen now. Sorry? I wrote something on the screen now. Can you see it?
Yes, sir. Yes, sir. I can see.
Okay. Uh, Sorry about that. I'm trying to. Technology. I'm trying to share the screen. Okay, no. Yeah, you can see the screen now. Yes, so this is the next topic that we are supposed to discuss. Matter. So you know this, what I'm going to be discussing today, the remaining part of the lecture hour today, and Friday will be on matter. So what is matter? Matter is anything that has mass, Abi, and occupies space. And all matter is made up of something, even if it looks like nothing. So it composed of atoms, ions, and molecules. So if you, before you refer to anything as matter, you must know that there are some students in the waiting room. They should go and join WhatsApp now. If they should go and join. So all bodies consist of matter. Our sense of sight and touch tells us that an object occupies space. How about in the case of colorless, odorless, and tasteless gases, our senses will fail us because they don't occupy space to us. So we don't know because we cannot see them, but they are still matter. They are matter. So you must know all this. Then there is intermolecular forces, which determines the arrangement and bulk properties of matter. All matter, regardless of states, undergoes physical and chemical changes. All matter. The changes can be microscopic. There is no observable change in the quantity of matter during a chemical reaction or a physical change. That's law of conservation of matter, that there is no observable change in the quantity of matter during a chemical reaction or a physical change. In other words, matter can not be created nor destroyed. It is just converted from one form to another. And I always use this as an example. If you have $100 and you decide to burn it, it's going to turn to ash or ashes, CO2. You know, when you burn it with oxygen, plus many other things, So if you are able to collect all this, you will see that the weight of your $100 will also be the same as the ashes, CO2, and everything. So, but what has happened is just that your $100 changed form from $100 to ashes. So, in other words, matter cannot be created nor destroyed. It is only converted from one form to another. Law of conservation of energy. Energy cannot be created nor destroyed in a chemical reaction or in a physical change. It can only be converted from one form to another. Burning of magnesium in oxygen gives magnesium oxide, Mg, plus O2 we give MgO. And we balance that equation that way. But it's not my duty to do that. States of matter. We know already. You know 3 states of matter: solids, liquids, gases. But there is the 4th state, plasma. I know you don't know. Some of you are hearing that for the first time. So we have plasma as the 4th state. So we're going to look at each of them. And you can see your ice water, your ice block is in solid state. Look at the temperature, is less than 0 degrees Celsius. Liquid, and look at the way the arrangement of the molecules in them. You can see in solids, the molecules are fixed together. In liquid, they are slightly free. In gas, they are more free. And in a plasma, they are even more freer than as you have them in gases. And so, and you can see the temperature range for each of them. All these are what you must look at in details, because when we set our questions, we look at all this. And since you'll be sitting for, what is it called? MCQ questions, MCQ, you have no choice than to look at all these in details so that you'll be able to answer most of the questions we are going to ask you. So our exam is MCQ, where you'll be given a question that will be supported with 4 options, where you'll be expected to take one of the options. And so we are going to look at properties of solids, liquids, and gases, as well as that of the plasma. So I think I'm going to pause my lecture here for today. I will now be able to maybe listen to 1 or 2 of you that will probably want to ask questions. So let me look at what I have here, so that feedback from you will enable me to know what to do when we come again. Participants. Israel Adene. Israel, you can unmute yourself. Oh, these are people in the waiting room, sorry. It's too late for them now because we're already almost done. So your comment, please, those. David Owolabi. Any question? Yes. Zakia, unmute yourself. Zakia, you can unmute yourself. Owolabi, you can unmute yourself. Owolabi, unmute yourself. Owolabi, unmute yourself.
Hello, sir. Good afternoon, sir.
Yeah, good afternoon.
Sir, you mentioned something about a test to be held on Zoom.
Yes, sir.
Yes, but how are we going to do it? Because even the percentage of us that are on this Zoom meeting currently are less than 10%. So if we are to be having our test on Zoom, I can't really understand how it's going to work.
Relax,
That everybody will be able
relax.
to
It's not going
participate.
to be on Zoom, but it's going to be online. It's not going to be on Zoom. It's going to be on Google Cloud. We're going to use Google.
Okay,
We'll put our
Google.
questions there. All of you will log in at the same time, and you have about 20 minutes to do the test. When we're ready for you, we're going to let you know.
Okay. Thank you,
Does
sir.
that answer your question? So don't
Yes,
be
sir.
afraid for now. Any other thing for now?
No, sir, that's all.
Favor Friday, is your answer on? Up, brother. To unmute.
Yes, sir. We can't still type our matric number on Zoom, sir. It's still
Sorry
too late,
about
sir.
that. But you should have done that when you came in, because you had all opportunity before I came in to disable everything. So if you've done that, it will have worked. Not to worry. If your name is there already, you'll be able to see your name. But if you have iPhone 27 on as your name, then we'll not be able to help you. Thank you. So see you on Friday. I hope today's one is better than that of last week, that of Monday. Sorry about that. And let me also tell you to please observe 1 minute silence for one of my colleagues that died yesterday. He's a lecturer in the Department of Mathematics. We lost a lecturer in the Department of Mathematics. So I urge you to just observe 1 minute silence for him. May his soul and the souls of all the departed rest in peace. Amen. Thank you, guys. So I'm going to stop today's lecture now. We'll continue from here on Friday. Thank you for your time. And forgive me if you think I've not presented the work the way that is expected. Thank you. See you.